Continuing with Venn diagrams. So we looked at this probability rule earlier on. A or B is the probability of A plus probability of B minus the probability of both. If we're talking Venn diagrams, let's translate. Or is union and refers to intersection. So probability of B is 0.4. So the entire circle of B is 0.4. A union B, A or B, so all of A and all of B is 0.7. Probability of A intersect B is 0.2. Find the probability of A. Well, we know that probability of A union B is equal to the probability of A plus probability of B minus the probability of A intersect B. We can plug these numbers in and we can solve. It's pretty straightforward if you look at it this way. So A union B is 0.7. Probability of A, we don't know. Call that X. I'll just leave probability of A there. Probability of B is 0.4. Probability of A intersect B is 0.2. So 0.7 equals probability of A plus 0.2. I combine like terms. Subtract the 0.2 from both sides. The probability of A is 0.5. It's basic algebra at that point. Now, mutually exclusive events have no common outcomes. Remember, the two circles in the Venn diagram will not overlap. And what that means is that if A and B are mutually exclusive, then their intersection will equal 0. And this formula for probability of A union B simply becomes probability of A plus probability of B. So we have fruit being selected from a basket that has apples and oranges. A represents selecting an apple, O represents selecting an orange. Are A and O mutually exclusive? And you better be thinking, yeah, because there is no way to reach into that basket, select a piece of fruit, and have that piece of fruit be apple and orange at the same time. It's just not possible. So, find the probability of A. What's the probability of A? Probability of selecting an apple is 8 out of 20, which is 2/5. Probability of an orange. There are 12 oranges out of 20 pieces. 12 out of 20, this reduces to 3/5. Probability of selecting an apple and an orange. That's 0. They're mutually exclusive. Probability of an apple or an orange, 2/5 plus 3/5. And then we don't have to subtract anything, so this is equal to 1. That should make sense. We have a basket with apples and oranges. If we reach in, we're going to pick one or the other every single time, or 100% of the time.